Before we begin, let me introduce our group members. Our group members consist of 3 members, which is Yasmin, Nurin, and me myself Isaf.
Assalamualaikum Madam and everyone. We are from group CS264 to B2. Today we will present our ITT400 networking project. The objective of this project is to design a simple wired and wireless network using Cisco packet tracer. Our network uses the private class C IP addressing scheme, which is 192.168.80.0/24. This is our network topology. At the center of our network is a Cisco 2960 switch, which connects all wired devices. The router acts as the default gateway with the IP address 192.168.80.1, allowing all devices to communicate within the network. We all include an access point to provide wireless connectivity for laptop and a smartphone. Our network consists of one router, one switch, one access point, one printer, 2 PC, 2 laptop, 1 smartphone, 1 web server, 1 DNS server, 1 DHCP server, and 1 FTP server. Overall, our network contains more than 10 devices, meeting the project requirement. All devices are successfully connected and can communicate with one another. Assalamualaikum Madam and everyone.
Hi, my name is Nurin Inshira binti Bahari. Next, I will explain the configuration and the functions of the main devices in our network. First is the router. Router 0 is configured with the IP address 192.168.80.1 on interface GB Internet 0/0 with a /24 marks and it acts as the default gateway for all devices in the network. Second is the web server. At 192.168.80.2, it hosts our website, allowing users to access it through a web browser. We enable HTTPS for a more secure setup. And in the file manager, we have hosted several pages, which is logo.png, copyright.html, hello.html, image.html, and index.html. As shown, the web page is displayed successfully, indicating that our web server is working properly. Next is our DNS server. At 192.168.80.3, its function is to translate domain names into IP addresses so users can access websites more easily. We create an A record mapping, which is www.sit.coffee.co to 192.168.80.2, which is our web server. This means any PC or laptop on the network can type that domain name into a browser instead of remembering the raw IP addresses, and DNS resolve it automatically. Next is the DHCP server. At 192.168.80.4, it automatically assigns IP addresses to devices on the network, making the network easier to manage. We configure a pool called server pool that hands out addresses starting at 192.168.80.51 with subnet mask 255.255.255.0, default gateway 192.168.80.1, and DNS server, which is 192.168.80.3 for supporting up to 150 clients. That's how our PCs, laptops, and smartphones automatically receive their IP addresses instead of being configured manually. Moreover, is the FTP server. At 192.168.80.5, it allows users to upload and download files through the FTP services. We create the user account, which is SipCoffee, with their password, which is buttercream. Next is printer 1. Printer one set up at 192.168.80.6 with a static IP pointing to our gateway and DNS server, so it's ready to accept print jobs from any devices on the line. Lastly is our access point. Our access point enables wireless devices such as our laptops and the smartphones to connect to the networks without using network cables. So that's all from me. Hi, my name is Nurin Inshira binti Bahari. Next, I will explain the configuration and the functions of the main devices in our network. First is the router. Router 0 is configured with the IP address 192.168.80.1 on interface Gigabyte Internet 0/0 with a /24 mask and it acts as the default gateway for all devices in the network. Second is the web server. At 192.168.80.2, it hosts our website, allowing users to access it through a web browser. We enable HTTPS for a more secure setup. And in the file manager, we have hosted several pages, which is logo.png, copyright.html, hello.html, image.html, and index.html. As shown, the web page is displayed successfully, indicating that our web server is working properly. Next is our DNS server at 192.168.80.3. Its function is to translate domain names into IP addresses so users can access websites more easily. We create an A record mapping, which is www.sip.coffee.co to 192.168.80.2, which is our web server. This means any PC or laptop on the network can type that domain name into.
I will demonstrate several network functions using our Cisco packet tracer application. First, we will test network connectivity using the pin command. Enter pin 192.168.80.2. This tests the connection between PC1 and the web server. As we can see, all replies are successful. Next, we will test the connection to the DNS server. Enter pin 192.168.80.3. The successful replies show that the PC can communicate with the DNS server correctly. Next, we will test the connection to the DHCP server. Enter pin 192.168.80.4. Again, all 4 packets are received with no loss, confirming a stable connection. Next, we will test the connection to the FTP server. Enter pin 192.168.80.5. This confirms that the FTP server is reachable on the network. Next, we will test the connection to the printer. Enter pin 192.168.80.6. All replies are successful, showing that every device on our network can communicate with one another. Next, we will demonstrate the FTP service by connecting to the FTP server. Enter FTP 192.168.80.5. We enter the username and password to log in successfully. The username is sipcoffee and the password is buttercream. Next, we should enter get ASA 842-k8.bin. This command downloads a file from the server. As we can see, the file transfer completes successfully, showing that our FTP service worked correctly. Next, we enter test quick. Next, we will check the ARP table using the ARP-A command. This displays the IP address and physical MAC address of every device this PC has communicated with on the local network, including our web, DNS, DHCP, and FTP server, as well as the printer. Finally, we will test connectivity to another device on the network, which is PC2. Enter pin 192.168.80.52. This confirms that PC1 can also communicate with other end device, not just the server, proving that our entire network, which is wired and wireless, is fully connected and functioning as designed. That's conclude our demonstration. Finally, we will switch to the simulation mode. The packet travels through the switch before reaching the destination. Since the result is successful, it's proof that our network communication is working correctly. That's all from me. Thank you.
In conclusion, we successfully designed a simple wired and wireless network using Cisco Packet Tracer. Our network used the 192.168.80.0/24 IP addressing scheme and include a router, switch, access point, server, PC, laptop, and a smartphone. We successfully demonstrate network connectivity, IP configuration, web service, DHCP, DNS, FTP, file sharing, wireless communication, and packet transmission using simulation mode. Thank you for your attention.